Okay, so hi, welcome everybody to this event source content repository pair programming session, crowd programming session. You'll see how it works. It will be Bastian and me working mostly on the CR, basically on the show and hide functionality of the content repository, and it will be until 10:30, so 1 hour and 15 minutes for now. Right, so I'll share my screen, I guess, right? Whoops. Inception.
Oh god.
So what is it about? I'll just open the ticket once more. So just to get into the mood, because I need a few seconds to get into the topic once more.
12.
12. All right, thanks. Right, so it's about hiding a node, and exactly we want to say if we hide a node, all subnodes should automatically be unreachable as well. So this should work recursively. And the problem is, of course, that if we do things recursively, if you hide the top level node, then things can go really, really slow. When we have to hide thousands of nodes below, basically, or have to do thousands of operations or millions of operations in PHP. So the idea was to be able to do that on a database level, that we on a database level actually are able to multiply out the recursiveness, so to speak. And the idea is that we will have a new table, which we call restriction, restriction edge on the projection side, which will basically tell us in which workspace are we. So that's the content stream identifier. In which dimension space point are we? So in which language, so to speak, we are. And then we have an edge between the origin node and the affected node. So that means the origin node is the node the user has clicked on, and the affected node would be all nodes below. And the idea, so just to try that out in the UI, or just to visualize it in the UI.
All nodes below doesn't mean below in the hierarchy, right? So not in the tree below.
Well, it does. I mean, with below, it's not below in the sense like underneath, but in the sense like deep down. So if you hide shortcuts, then all the nodes in here will have. So there will be connections from this node to this, from this to this, from this to this, and so on, right?
Yeah. Okay. Got it.
So that's like the idea about it. So that we on at the query time we can hopefully efficiently determine if a node should be hidden or not, just by asking, okay, do we have incoming restriction edges? And if they have, then we know, okay, it is hidden because of some node above which has been hidden. So.
But the affected node aggregate identifier you just mentioned. Right?
Yeah.
In this, if you hide the shortcuts node, that would be which one exactly in this example?
Well, the affected is so the origin node aggregate identifier is always this, I don't know, this one, right? B something, and the affected is first the node itself, so it has a restriction to itself because it itself should be hidden, and then it would be the node aggregate identifier of this one, 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 and of all content nodes below.
Okay, but so in the ticket it says affected node aggregate identifier singular.
Yeah, because we will have so for this single hide operation we will have 1, 2, 3, 4, 5, 6 rows in the database plus all the contents. So an individual row for every content. So that's the content of the database table, right?
It's not the event.
Not in the event, yeah. Exactly. Because in the event this will not even appear because we'll multiply that out in the database.
Okay, just to recap. Yeah.
Right. So I'll try to add some to-dos in the implementation.
Maybe I just add one addition. So we say right now we just capture the intent basically of the user, or more what happened, because the event is only published if the user is allowed to hide the node. But we don't record the hierarchy results, so we don't record which nodes exactly are hidden, because we multiply that out. And the idea is in the future, was kind of derived process to publish those events, maybe not for every stream, but at least for the live event, so that at least a different projection could easily react on hidden nodes, for instance.
Just
exactly. To recap, but this would be out of scope for today.
Exactly. So that means this is actually the feature later on that you are able to know that you are able to subscribe on. Has the visibility of a certain node changed, right? So because of some node above it being shown or hidden. I think actually we won't get done with the implementation, but we just get as far as we can. So let's see. So what do we need to do? I think we need to model. We need to update command and event. That's the first step, right? We need to create a test case without children. We need to create a database table for restriction edges, right? We need to
sorry, could interrupt, but could you quickly say a word about the restriction edges? Because I thought it might be just another color of the graph, basically, but this is not how it works.
Yeah, let's just see. So currently the projection consists of these three tables, right? So we have the node table, which is actually containing all the properties, the node type name, the node aggregate identifier, in which language we are, and so on. It does not contain any structural information. So compared to the node data table, we don't have any node path or anything here. But we have this is stored in the hierarchy relation, and in the hierarchy relation, we know for which content stream, aka workspace, for which dimension space point, aka dimension in the old wording, we know what is connected with which, and the join is always, it's called the node anchor. So that means the relation anchor point, that's actually the table column we will be joining on with the hierarchy relation to get the structure. So you see for the root node, for instance, so you see it's the root because it has the parent special anchor of zeros. It connects this single node in all different dimension space point and content streams workspaces. And the reference relation is not so relevant for us now. That's basically we don't store the reference properties directly in here, but we store them as extra relations in an extra table so that we're able to traverse them from the other side as well. So now for hiding showing, we could actually, it would be an option to just add a new column in this hierarchy relation table to say hidden or not, for instance, and then update this recursively. That would be an option. But the problem is, I think it would be pretty expensive to compute because we cannot easily. So it's easy if you hide a node, for instance, then this would be easy because you could just you would just recursively traverse through the hierarchy relation in the database and then set all the hidden flags to 1, right? So to true. The problem is if you remove a hidden flag again, then it's more difficult because you can actually have to you have to calculate what the new hidden state is depending on if the parent has been hidden or not, or these kind of things. But if we model it as extra tables, then we can just, and as an extra table, we can just remove all the certain set of edges really easily. See what I mean?
Yes. I was just wondering, because if we say hide, of course it basically means disable the node, or
hide is a special case of restriction. Later on we will have other restrictions, right?
That's true. That's why I was in the first, I was just thinking Well, basically, it's the same as delete if you have a trash can and you can undelete it, but it's not the only kind of restriction we'll have, so it makes sense.
We have start time, end time, and these kind of things, and these will all be easy to implement, right? But with so it's basically update the projector, and then after we've done this, update the DB queries on the read sides, and last but not least, use content context correctly and find better name. Test should run through now. So okay, so basically I think so that's basically what we have to do. Start with the command event, then we can start with creating a test case which will fail, but which will be the thing which we can iterate on quickly. Then we'll can create a database table for the restriction edges. We can update the projector. I think this will be pretty quickly, these kind of things.
What does it mean, updating the projector? So it creates the edges.
Exactly. So I can just So
just the way.
Create edges create restriction edges in database. Yeah.
And then update the queries on the read side to kind of respect those edges.
Exactly, to respect those edges, to see if we want to filter out hidden things and we have a hidden restriction basically applied, then we just remove this line. That's and the content context. So that's a bad part still. Well, no, it was context. It was called context parameters. That was the thing. I'll just have to change the name. Content
parameters. No, context parameters.
No, yeah, you're right. Context parameters.
What is it?
Yeah. Well, it's basically it's a very ugly name, but it contains infos about should we show invisible content, what are the roles. But I totally dislike this kind of name. I think it should be something with restriction, or I don't know. So I mean, it's basically so to do find it.
Context is a bloated name.
Yeah, context is like foo or bar or nothing, or it's like not sensible at all.
But why don't? I see. We have to extend it so we can still show the nodes.
The thing is, we already have it, but we don't respect it currently. But we don't use it properly in all cases. In most cases, currently we just instantiate it at all places. We don't pass it around properly and so on. So there's some work to be done there.
Well.
So
get that far.
No, definitely not today.
Okay.
Let's see what I've just been doing. I'll just revert these two changes because I've already started with a few things, but it was not much at all. I fixed the editor config so that you actually can auto-format the feature files again. Right. So let's start with the show and hide. So let's start with hide, I think, right? Hide node. So the hide node command.
Yeah, maybe we should just do that first.
Yeah, exactly. So it has the content. So that's this thing, and I think we also have a test for this hide node. Not
so we're done.
So let me just check. Given the command, yeah, there's a hide. Oh no, actually not this one. So let's just see test.
Is hide node the right name? Because for creation we have this create aggregate node with.
Yeah, it is, because it's not about hiding the full node aggregate, but you can specify which parts of the aggregate you will be able to hide. I would say.
True.
So, and here was this, I was single node.
And to hide the whole aggregate, you would have to do that in all the languages.
Exactly, you would just specify all the full set of the full dimension space, basically. So
yes.
So let's see if the test runs through. FB had tests. Yes. Event source content repository. Test B had features. Where are we? Event source single node operations. Right. So that's the one we will be running now-ish. So it's interesting to talk and think aloud more explicitly, but it's not bad actually. Come on.
And to have someone interrupt you all the time and ask stupid questions.
No, you don't ask. I'll just open this stuff already and see if this runs through. Right, I wouldn't save it yet, but I can already start. So we have the content stream identifier. We have the, oh yeah, it ran through. Wonderful.
So for everyone following, you're now at the command, right?
Right, I'm at the command. I'm at the first step. Right. Yes. So we are in the context node command, and the hide node command has the content stream identifier, aka workspace in which we are in. It has the dimension space points. Now I'm not sure regarding naming. Normally we call this visible dimension space points, but in this case I would rather call it something like affected dimension space points. So because it's actually it's saying you want to hide it in this and this and this dimension space point. So in this and this and this language, for instance, makes sense like this, right? I think
absolutely. I think affected would actually always.
Yeah, I'm actually not sure because on the read side, actually, it's really about visible. So well, maybe we can change it. I'm not sure yet, but let's see where we go. And we are actually we don't have the node identifier anymore, but we have the so we will phase this one out. So the node the node identifier which we had is somehow like the flow persistence identifier in the old build, but it turns out we don't actually need it anymore. But we just work with the node aggregate identifier, which corresponds to the old node identifier. Yeah, a little chaotic.
But why don't we then, if we don't need the other one, just use node identifier again?
Because it's something different. It's because it is for the aggregate. It's the identifier for the full aggregate. So that's just more clear. Yeah. But we won't have the naming conflict anymore when we when we get rid of one name. So now we can generate the constructor. I can generate the getters. Oops, and here we go. So that's node aggregate identifier to node aggregate identifier to which the user intends to hide.
You're free to skip the doc comments and I'll happily add them afterwards.
Yeah, okay, good. Yeah, fine. So now I would expect the test case to fail because we actually changed the command, so it shouldn't be able to map it anymore. And I'll just run.
So we already had we already had a test for hide node, but it did not.
Well, it's just testing. It is for now. Let's just test the single thing. How was it like this? It just tests tests that we get the certain events emitted basically. So it's just going from command to event. This part is not calling the projections. Yes. And for that we don't have a test case yet. So, but now I can go and write. And here's some magic in here. So we have so we can specify node identifiers as strings here, and they will use internally UUIDs so that the tests are more readable, actually. So that would be node aggregate identifier. Now we have to think through that's actually the NA identifier. That's the node we have created, right? So we have to, it's basically creating a single node up here.
Oh, okay.
And so we need to use the NA identifier here instead of the and then we have the affected dimension space points. And I think, how does it work? I think like this. I'll just format this part. And now I have to check. I think actually we are having no content dimensions here.
Okay.
So that means we just say we don't have any. Oh, actually, we have one. We have one, and that's the empty dimension space point. Because if you have an empty dimension space, it's still consisting of one element, which is the empty one. So then I have this 4 events published, and the third one, which is exactly the hidden node, it should contain exactly the same things. And this will now, so the top part should now run if it all works through exactly. And get node identifier and the node command handler. Now we actually need to fix the stuff. Handle hide node.
Node command handler. Okay.
Yeah. Here we go. Exactly. This get node with get node identifier, and actually, this is now. So this is a soft constraint check. We check that the node exists, and now we have to change this get. So because get node internally used node by identifier, and that's wrong. So I've just created. I'm not sure about the name yet. That's not so bad because it's just purely internal. So get node will be removed eventually, and then we can rename the stuff again. So it's basically get node with origin dimension space point. So oops, where we go? Handle hide node. So just to be sure, actually, what I would need to do is probably go through all get affected dimension space points.
So what are you trying to? You get the nodes from the read side to check if they can be deleted.
To be hidden, exactly. As I'm basically saying, okay, this dimension space. So I'm just saying get node. So I say. So I'm saying in this on the read side, it should exist, and actually its rows it's also not well named. Maybe we should, instead of get node, it should so it's more like assert node with origin dimension space point exists. Because actually it's about throwing an error in case.
It should also.
Yeah.
It should also check if it's already hidden. No.
I think that's not a problem because I wouldn't say that's a problem because that would be idempotent. So you could check it, but I would say it's fine because it could happen that some dimensions are already hidden, for instance, but not all of them.
Okay.
So assert node with origin dimension space point exists, content stream identifier, but that's a good idea. So I just write these nodes down. Node code on. Just as
maybe we add a test for
this. Test for this.
Exactly. But at which point would we check if the user is allowed? This would.
I'm not sure yet.
Okay.
Probably also here somewhere. Yeah. But we don't have these kind of access checks yet.
Yeah.
In place. In all given dimension space points, that means exactly. So that means the node should exist, and then we can just say node was hidden, content stream identifier command. I'm just thinking about if I should switch it around because I think it makes more sense to turn it around to say, okay, it's this content stream identifier, it's this node aggregate, and it's this set of affected dimensions. In this case, it makes more sense. Usually, it's like the other way around, but it depends a little on the use case, like in which order the parameters make more sense. So,
gotcha.
I'll just regenerate this stuff. Constructor.
It's good that we only use objects now, so you
totally.
can't switch the arguments by accident.
Totally. So, and then basically I can just in the event that's pretty much the same, so I can just copy paste things here. Get a constructor. Getters. So, and what I have to implement once more, what is important now is I have to implement this create copy for content stream method. Otherwise, it cannot this event cannot be rebased.
Oh.
Well, actually, I'm just thinking, is that still right?
Can you quickly elaborate? So
I'm actually
not sure
if you actually even need that anymore. It's used in public.
Can you think out loud quickly? So
yeah.
the event
So basically, it's for what we do for publishing is we have to rebase all the events, and but I'm just thinking. Actually, I thought we stored the initial command and we replay this command, and that's something which I'm. No. I remember. Yeah. So actually, it's two cases. So in case we, so currently it's the case when we rebase, we replay the commands, right? When we publish, so we don't have to rebase, we just publish. Then we just copy the events. So that's at least how it's done currently. It might be unified, but because we say, okay, it has run through already correctly, so we can just apply the events one by one, and we know that the state will be exactly the one we want to be. So that's why this has been done like this for now, but it could be changed.
But no, I still don't get it. So why do you need the method then to replay the event?
To replay the event on another content, to basically take the event and apply it on another content stream. So to say, okay, you have done this in the user workspace and you want to do it on live, but still, yeah, it's a different mechanism we are using for rebasing and for applying to the base. Sure. And I'm not sure if it should be the same or not. That's something we need to think through in detail.
Yes. Okay.
Right. So can you take this as a note, please?
Notes, yes.
Just because that's something we should revisit at some point. Maybe have just a ticket for it. Right. So that means the node command handler should say get content stream.
Lass den nicht da drin, den musst du mir wieder geben, den Fetzen, okay?
Hi.
David, you're live.
Oh, hi. Oh, sorry. I thought I'm on mute. Oh, sorry. I'm at home and my daughter needed something.
All right. So then we say, okay, node was hidden, and then that's basically it, right? That's what we would expect. What is it? Actually, it's missing the node aggregate identifier here. Command. Yeah. Makes sense. So let's try and see what happens. So node was hidden, get origin dimension space point. I think actually, the problem is now that node was hidden. The dimension space point set. Oh, where does it crash? Graph projector. Yeah, that's actually really good. That's actually really good. Because that's actually in the projection side of things already. That means we can just disable the node was hidden. Yeah, we can just disable.
What did it do before? I thought the projector didn't even.
No, it just it stored it on the node itself, pretty much the old behavior. So that's something we have to get rid of anyways. But
yes,
it looks like the old style. But well, maybe we don't need to get rid of it because maybe we need it still for the UI. But that's something we need to figure out. Okay, and now that's a detailed problem, like how the JSON looks like in node was hidden. It's looks. I think I can say dimension space point set.
Spelling.
Thanks. Oh no, that's not right. Array doesn't match expected type string. That was a little nasty. We have, I think, I can write it like this. I've had this recently already, but that I have to think through there. Oh yeah, that's what was it? Just 1 second. I've done something there. Where was it? Affected. It was that property what I worked on recently, so that must be something with that property. Or property was set is actually the interesting question. Dimension space point. Oops.
So most of the events have a dimension space point, and now we have the dimension space point set. But can't you only ever hide a node in one point?
No, you can actually. No. To the contrary, I think that's a detail of the. Let me just check if this works. No, because the current behavior is that you want to take care of the shine throughs correctly. Yeah, so that's good.
Okay.
So you see what, so that's this assertion type versus type. That's also just the detail of our testing setup. That's something I actually forgot what it was. It was just conversions on different places in this event assertions, which we can probably clean up. But yeah, something for later.
Okay.
So, and then he says, okay, visibility hidden is hidden, and that fails. Okay, that's fine. Okay, so that means actually the event runs through. And we can probably create a new one saying hide a node, hide a non-existing node, should throw an exception, right?
Mm-hmm.
Unknown identifier is executed. Let me just check. The command is execute. Where is it? With payload. Exactly. And exceptions are called. What's this looking for?
Where are they called?
Well, they're just stored in a variable, and then I can just assert them, and then I expect.
Oh, okay. But we want to assert that they are thrown, not that they are caught. But just a naming thing. But
yeah, feel free to adjust these kind of things.
Yeah.
It's really
just take notes and then
the last command should have thrown. That was the thing. Then so of type. Oops. What actually do I accept? Node not found, probably. Let's see if that works. Oh, okay. I have to run the full thing now. Show a node. Yeah, hide should throw an exception. That has worked. And now I'll just modify hide a hiding a non-existing node in a certain dimension. Right. So now I would use NA identifier. So I just want to see a different kind of error, right? I want to see language E doesn't exist. So that's that's the same error. Yeah. And still one failure, which is the one above, but the rest worked. Yeah, I think that's just really nice that you can so easily get a quite nice test coverage for these kind of things.
Yeah, I just wonder if it would maybe make sense to even specify what kind of exception, because
we do. Node not found exception. That's
okay, got it.
It's not saying any exception, but it's.
Oh, okay. So so forget my previous comment. So we're actually asserting that.
Yeah, we are asserting the type.
We just with the caught we
enable that it's not thrown into the.
Sure.
That we can assert on in later, because otherwise it's more hard to do it. So feature edge. Feature adjust command and event.
I think his son doesn't like the feature.
No, he seems to be away from somewhere. But hopefully it's something. Well, if it was bad, then they will probably tell me in a bit. So that means command event is done. Now we can start with the projection side of things.
Well, in the to-do list, the first test is also done, but
no, the test case. Yeah, the test case without children is something we now need to do, which is part here is saying the graph projection is fully up to date.
Yeah. Mm-hmm.
And I expect the node to exist in the graph projection, and the node. Actually, that's not wrong. That's actually wrong because when I by default query, I want to say the node to not exist.
Mm-hmm.
And let's just check the event to exist in not to exist. And not if it's hidden or not, because it's just not there, right? Because and the second thing is when I am in how was it called? I am using context parameters. How did we specify them in the? I just think we had it. In context parameter. Invisible content shown, right?
Mm-hmm.
When
That's the right syntax. Is that the right syntax?
We don't have it yet. We have to.
Oh, okay.
But I'm just. How do we write this?
Can't we have like inline JSON in something like this?
Yeah, sure.
I don't know.
But I don't want to specify the full context parameter set. That's the thing here now. Yeah.
Yeah.
Maybe do it like this. When context parameters are set to invisible content shown, because then we can specify defaults.
Yeah.
Like this, maybe.
Yeah, I think
And then I expect a node to exist in the graph projection. So then I have to be able to find it actually. That's
cool. And now, okay, there's no test for knowing that a node is hidden, but I think that
exactly that's still missing. I think you'll find them. So when context parameters are set, let's just.
So 20 minutes left. Let's see how far we get.
Oh well, actually no, half an hour.
Sorry, yes, more even. Yeah.
But it will not be enough. Okay, but just get as far as we can. So let's hide a node. Which line was it? C56. I mean, I'll probably continue building it in the afternoon anyways, right? So but here now we get an error. So now we need to we have a test case, and now we have to create actually the database table, and now it gets more interesting. So database table, right? The database table is in, so package wise we are just switching to a different package because the projection is in the content graph package. So it's not in the event source CR anymore, the projection itself. I want to highlight that. So today is the 22nd.
Oh, you write doctrine migrations manually?
How do you do it?
Yeah, hardcore. I usually create an entity and let
we don't have an entity.
Yeah, I just created the way of it.
Okay. Create hierarchy edge. I got no restriction. So let's just. I'll probably find some create statement. That one looks useful. Especially, I'm always not sure about all these like what collation and all these things.
That's what I meant, but yeah. Good idea.
So Neos content graph, whoops, restriction edge. It has the it has the origin node aggregate identifier. Something I'm also not still unsure is whether I would actually like to spell it uppercase, but I'm not sure if it ends up with some problems if we use proper casing in the database. So
it's usually it's ignored on the database level.
But it would be easier to read.
Yeah, right. But we could also use underscores.
Value actually, right? So for the return value in the select star, then it's different.
It's different, it's true. But well, no, I think it's always lowercase. But if you map it to some model, then it's converted. Anyways, but I wonder now we use value objects, but in the database we just use simple varchars and no doctrine mapping or something.
No, it's all plain DB
mapping.
We don't have any. We don't even have
outside.
We don't even have ORM here.
Okay.
So there is no ORM which you could.
Yeah, but even the debug from doctrine.
That's what we use.
These types.
Which one? Okay. Well, then that's might be something interesting to use. I mean, it might make sense because it's not varchar 255. It's actually too long for such an identifier. Probably.
Yeah. Okay. I'll take notes.
Yeah. So origin affected node aggregate identifier. And then it's the content stream identifier, content stream identifier. And now it's a question about the dimension space point. That's something I have to check. The dimension space point I think it's actually the dimension space point hash which we need here. We don't care about the space point itself.
Okay.
So
yes.
I'll just check. Yeah, it's all. We waste a lot of space here in the database, but
what's that? A lot of space?
Because the length, the hash is always length, for instance.
Yeah.
So, and the primary key should actually be all of them, because it is basically saying, it's a for tuple actually, which needs to be.
Let's quickly check content stream. Sure, dimension hash effect. Yeah.
And later on, you would have additional restriction properties like saying, start time, end time, these kind of things.
So.
Actually, I'm missing. We still just forgetting. Create a test case with children. We are not able for. Create a test case for fork content stream. So. Because we created a new database table, we actually need to copy it also when we fork and implement a copy on fork.
Yeah. Can you quickly go one tab further to the backend for a minute?
Second, yeah.
Yeah. So what the projection does, if you hide the shortcuts, it will create one entry in that new table for every connection.
Yeah.
And affected would always be the node that is affected, and the other one is always shortcuts.
Exactly. The origin is always shortcuts. Yeah. So let's see, flow doctrine migration status. Okay, let's see if I have SQL errors. No? Woohoo! So, okay, that means we have this one now, and now it's actually about, exactly. So now actually it's the graph projector. It's saying when node was hidden, and now we need to do something.
Nice.
So what we need to do is we're starting a transaction, that's for sure. Sorry.
as you.
Yeah, exactly. It's just saying. So transactional. What is doing? It is doing two interesting things. The first one is it's saying, well, it's wrapping the stuff in a transactional database block. Oh, 1 second. That's good. Aus dem Bett gefallen. Oh je. Nach dem Schlafen. Oh je. And the second thing which is happening here is emit projection updated. This signal is extremely important because because we flush caches, so in-memory caches when the projection changes. So normally updating the projection and reading from the projection is happening in different PHP processes, right? So. But it might happen that is like in a test case, it happens in the same one. So you do things and then you query the projection, then you update things and then you query it again. And we have in-memory caches for performance, so that if you ask the subgraph two times the same thing, it actually only does one database query. And it allows to. This is how we heavily optimize the read side database query wise with this scheduling. So we need to ensure that every time we change something, actually we need to flush this in-memory cache, which is empty most of the cases, but like not in all of them. That's just the explanation for.
Okay.
So when node was hidden, so that's this transactional block, right? And actually, I'm just thinking where we can actually speak. I think we can speak where we take on reading on deletion when node was removed. Yeah, exactly. Because I think actually here we have remove relation recursively from database, including non-referenced nodes. I think that's pretty much.
Oh, but deletion removes edges, and we actually want to add some
new ones. But I just need to. We need to recursively traverse through the nodes basically, and that's what we. Or actually, but it doesn't do it. It doesn't.
Can't we do it with one?
Yeah, I think we can
insert?
actually. This is also not good.
No?
Yeah, we have to do it with one query, definitely.
Yeah.
So with one query, this means we need a query to. I just need what we can do from this delete what's removed is I can at least copy parts.
Oh, I get dizzy from watching you.
What's hidden? Sorry, that's just it will improve quite a bit in a second. So and now we need a that's the projector and right. So also I'm not so happy with this package structure in this package yet because the projection side that's actually the right side of the projector and repository is the read side. So that's just naming wise not good.
Oh, indeed.
It doesn't really matter because you never directly get the content subgraph, but you always go through the interface, and then it doesn't matter where the class is located, but it's still not good. But that's something maybe you can check. So yeah, exactly. I'll just copy the recursive we have because it's pretty much it will be at the end. It will be a recursive common table expression. So that is what we need. So
it will be a recursive common table
expression. What do you mean?
I didn't get that. It will be a recursive.
Yeah, it will be. It's called so there's a so-called common.
Common. I understood comment.
Yeah, okay. Right. So there you can actually write a statement like a subquery above, and recursively you can even do it like you can traverse something, and that's what we need to do. We need to recursively build up the set of node aggregate identifiers, which we want to point to, and then we can create the.
Crazy. Is that compatible with the?
It's yeah, modern MySQL. Yeah. So what do we do? Yeah, exactly. So with recursive tree, so that's actually the name of our table. So and what we have is basically two big parts. We have an initial part. This is the first select statement here, and then we have the union part, and then comes the recursive part. So what we do is actually, what do we need to do? We need the node. We need the node aggregate identifier, right?
Mm-hmm.
Yeah, we need a content stream. That's of course, but actually we don't need it because we always stay in the same content stream identifier. So that means we need the node aggregate identifier and the dimension space point hash. That's the ones we need, right? That's the targets we are actually aiming for.
Yes.
Parent we don't need. The level, the position, I don't care about that. So, and what we now do is actually we select from the node, we join it with the hierarchy relation because we need the
hash point.
Exactly, the dimension space point hash. Actually, right. Exactly. Yeah, it's actually correct. So this way we can specify where the node identifier is actually one of. And actually this now the node aggregate identifier is always the one entry node aggregate identifier, right? And the dimension space point hash is now in the dimension space point hashes, right? So that's the
set.
Hidden false, not relevant for us here. Is on the right side. Formatting we can do later. So now we do one. So let's just see. Then we do one child query step. What do we do now? So let's just try out this query in the first place. I'll just check the single. Just run the single table, the single query once more, because then we have just very few nodes in our system, and it's all very easy to. Yeah, exactly. 2 nodes, two edges, pretty easy. So that means the content stream identifier is just 1. That's something we can just take this one. Oops. The dimension space point hash. Oh, let me just check one thing. I just have an idea. Let's see if it's installed. No. Okay, because in Plumber you see the SQL and you get these things automatically replaced. So that's a little nicer than. But yeah, we can do that. So that means the what did we want? The node aggregate identifier we wanted to know now is the 7 something. So it's the first one. And the dimension space point hashes of the hierarchy relation is this 7.5 thing. So this should now return exactly. It's actually returning this single node, and that's it, right?
Yeah, that was obvious because there was only one. But
yeah, that's
okay. Well, that's fine.
Maybe we can actually. Let me just think. The good thing is actually we can now. Let's just also do that. In the test case, we'll just create a new node because we need it anyways, and it's probably a good idea. I think which was the file? I'm forgetting. Single node operation. I think I'll just change this to hide node now. I think it will grow anyway.
Yeah. Yeah, I think it's a good idea to do that around.
I'm not sure yet on how to do it best, basically, but
I think use case is a good idea. We don't have that many hide node, move node.
Yeah, that's true. But it's more a bigger thing than the hide, show. Here we go. So, and then we just add another node. So content stream NR child node aggregate identifier. The parent node identifier is node identifier, and that's the child node. Doesn't really make sense because it's just it's testing its content, but it doesn't matter. We can nest. I mean, we can just event-wise we can just nest it. So let's see the hide node feature. Now I would actually expect two. Exactly. We have one more relation, one more thing, and still this one will still return one query. That's right. So back to the graph projector. So now we join it with the recursive step, and what we do here is exactly, and this select must now return the same. It must return the same fields as the one above to make it work. So. So because they are joined in one single, and the nice thing is you now say I select from the tree. So that's the reference of this table, and this will happen as much until no new records are generated. So SQL does it again and again and again until the set of records is fixed. That's what's happening. So we join on the hierarchy relation. We say parent and child are connected. So that's always how we use it. P is always the parent, C is always the child in all SQL we are writing, and H is hierarchy edge. So if we have just one edge. So we are saying, so right, what we're actually doing is, right, we are joining from the, actually we still need the relation anchor point of the parent. That's something we still need to do, right? Because we actually, we join on the tree here with relation anchor point, see it? So we actually need this, actually it makes sense because we, that's the thing we want to join on, or we need to join on internally. So the content stream identifier is content stream identifier on the edge. The dimension space point edge matches. That's not what we need. And that should be actually it. It's just a recursive traversal. Right.
And this gives us, it's just.
It gives us all. Let's just try it. Let's just see this where here. It just, dimension space point. Here I have to still put the content stream identifier. Still also hard. To fix this. N relation anchor point and field width. Actually, he's told. Yeah. In this, I think. Wait a second. From the node recursively, we join from the tree. Where are we actually? Hierarchy. Okay. It's called C. It's the child node here. So it's C. The child. Well, it's actually the hierarchy relation. It's the child node. So the dimension is on the hierarchy relation. So okay, exactly. So now what we should get actually is the child node, the recursive child nodes of this node, right? So that means all except the root in this case. And so, I mean, I would say it seems to work. So let's check it again, like conceptually. So we select from the child the relation anchor point, the node aggregate identifier we are interested in, and the dimension space point hash, because that's what we need for the insert into later on. And then we do one step. We basically say we are at the parent. We join with the hierarchy relation on the parent node anchor being the relation anchor point, so meaning like the incoming edge of the hierarchy relation, and then we join one step further to the actual child node, saying we only take the edges which have the correct content stream identifier and also the current dimension space point hashes, right?
Mm-hmm.
And that's it. And then we have this query. So select star from pre. And actually, what we now need, so that's actually what we need. And now we actually just need to do this insert into stuff. So that's, where did we do that? We did this before as well, I think, in the copy. Let me just check. Copy. Let's insert into, then you specify the table, and then you just select and ensure it's the same thing. Okay. That should be doable.
15 minutes, that should be.
Yeah, we that's we will still do, I think. So that means, yeah, this is the common table expression. So now what we do, insert into hierarchy edge, not hierarchy edge, a restriction edge, right?
Mm-hmm.
And I'll just specify the fields here. I always do that because it makes it more explicit. Contents.
Yeah, absolutely.
But not an affected, no. So, and the values are.
Yeah. Don't you have to write values?
Oh, you can just insert into select from.
Oh, right.
Select. So now what do we select? We select the content stream identifier. I mean, that's pretty easy because it's the same. Oh, actually, we don't even have it here. That's fine. Because it's a fixed one.
Yes. Okay.
Yeah, the reason why we need this dimension space point hash up here in there is because we have a set of dimension space point hashes, and we have to basically, what we are doing is we are traversing in all of them at the same time, right?
Mm-hmm.
So that's why we need to track them here, but the others we don't. If we would have just one dimension space point hash, we could also just get rid of it here because we always have this just one, basically. So then it's correct. So that means so the content stream identifier is the one we need, and that's the one we pass in, right?
Mm-hmm.
Dimension space point hash is the one we get from above.
Mm-hmm.
Origin node. Content stream identifier as origin node identifier, and the node.
We really have to check if we can use proper case.
Yeah, it's
confusing.
Node aggregate identifier as affected node aggregate identifier. That should be it. So the node aggregate identifier from the tree above is the affected.
Yeah.
So what do we have to pass in? Everything which is, so we have to pass in the entry node aggregate identifier, which is just event get node aggregate identifier, get content stream identifier, and so, and for these points, let me just check. We have this point somewhere different.
You cast it to a string.
No. Yeah, I know that's something. Let me just check. There's, I think, in the content subnode. Yeah, this was it. With the parameter, you could specify the parameter type. Let me just check. Exactly, and this was yeah. So maybe we just use also this SQL query builder because it's it allows to add these parameters more nicely. It's just a small wrapper class, basically, which I've created.
And these parameter types are, by the way, exactly the way how you can.
That's true. They are. These are specific, right? So, well, actually, I just specified it. I think I can say the parameter types here, right?
Yes.
Actually, it's let me just check. It's still not enough. Sorry. We need this exactly.
Can't we move that to the set class? This kind of logic.
I don't know.
Something like get affected. Sorry, get dimension space point set to array or something.
Yeah, you probably. Can you just write this down? I mean, that's all very valid points, and maybe it has it already. To string count get iterator. It does not have it currently. No. Wait. Get point hashes.
See? Oh, but that's only the.
That's good. That's actually what we need. It's the.
Okay. Let's just cross out my node.
Get a minute. Dimension space point hashes. That's actually what we need. And what we need to do is to say dimension space point hashes is of this funny type, right?
And use custom. Oh yeah, I already wrote that down. I think in the long term we could instead just really pass in the dimension space point. Oh, it's the dimension space points. Yeah, and then say the parameter type is dimension space points. And then we can
but you need to distinguish between the point itself and the hashes.
Yes, but that would be two different parameter types.
Okay, yeah, sure.
So we don't move that.
So let's try this out. Now the Spannung steigt here. Let's see if we have this table somehow filled.
Yeah, okay. Success.
So still will not run through, obviously. Origin node identifier param. Did I mistype? Origin. Right. The origin node identifier or the entry. Yeah, it was just. Okay, that's an easy one.
Why did you call it entry?
Because it's the entry of the tree traversal. We can also call it origin if you like it better.
No,
entry is probably.
Okay. Just.
Access, insert into, select, insert into, restriction edge, insert into.
Wow, red on black is really easy to read.
But it's okay. Intro, restriction edge, content string at line 40. It's not the question what's line 40 in here. That's 424, 46. Might this be that that this insert into is somehow wrong? Let's just see.
Can't you just copy it and try to execute it manually?
Yeah, 1 second.
Mm-hmm.
It might be insert into select. Oh no, actually it's select.
Seems right.
Oh, actually that's what we are doing here as well, right? I hope it actually works with this. I didn't try if it worked. Insert into CTE if it works in this common table expression. Insert into. Yeah, well, I mean, why shouldn't it work? Actually, it doesn't make sense to not work.
Can you just copy the insert statement and execute that on your database?
Yeah, but it's not really helpful because I have to specify all the parameters now and so on. So it's a little more work to just.
Okay.
You see? So what is interesting is that it says this is the error actually. Insert into, yes. What we can also just try is insert into, oops, not so nice, obviously.
Sure. It's through the Hangout compression. It's really hard to read that.
Restriction edge. Okay, so but what might be a problem? Actually, do we do it the same? Insert into. Might be a problem the way I do this. That I do the select. You know, that this is still a problem. Maybe. Oh no, actually. Okay, I got it. You're not able. You're not able to use parameters here. So
you can't you just use it from the tree? Sorry, from the. Well.
I could also add. Of course, I could also just add a new column called origin node identifier, which that would also work.
Yeah.
So let's see. Access restriction as insert into restriction. Select.
Now you can copy that thing.
That's true. No, I can. I can. You're right. I have this tree query already up here. Insert into. Let's try it easier. Let's say.
No. Okay.
B, C, D. Insert into CTE.
I think you always have to specify the columns.
Oh no, you don't actually. I think. Let's see. Select from tree. So that actually looks good, right? That's actually what I expect.
Two minutes, I think we will fail. Too bad. And as usual, SQL was the
probably one detail thing somehow.
But can we join again later?
Sure. Yep. Let's try that after the other session. Let's get it done. Yeah.
Cool. I gotta.
Will you join the other session or not?
Yeah, I'll come a bit later.
Okay. All right. Then. All right. Yeah. Okay.
See you later.
See you then.
Thanks.
Bye. So we are switching I hope it was somehow useful. We are switching now to the other session. I'll just open a new Hangout so that we get a new recording, and then I post a new link. So see you in a few seconds there. I'll post the link again. See you then. Bye.